Hi, I'm Chris with Sanderson Test Prep, and in this video we're going to take a look at graphing polar equations. We're graphing rose petals, and now we're dealing with sine. So in one of my previous videos, I showed how we can graph a cosine n theta for rose petal equations, and now we're looking at the base equation of r equals a sine n theta. And some of the same things will hold true. So if n is odd, the number of petals that you have will equal n. If n is even, the number of petals that you have will equal 2n. But although that part looks the same, graphing your sine functions for rose petal equations tends to be a little bit more complicated than cosine. And here's why. It's because when n is odd, we always know that when n is even, it makes things work out a little bit nicer. They tend to be symmetrical, a little bit easier to graph, and in terms of finding the angles and visually, it looks a lot easier on the mind when we graph something where n is even. But when n is odd, that's oftentimes where we have a few tricks, and sine is definitely no exception to that. So let's take a look at what happens when n is odd. And we'll write out our first few odd numbers, and this pattern will continue, but just want to make sure we have enough of a sample for us to appreciate the pattern, which is normally when we just had a circle. So if we said r equals, and I'll even do it real quick, let's say r equals 3 sine theta. So that would be a circle, and if we remember for circles, that would be a circle with a diameter of 3 along the y-axis in that positive direction. So if we think of that circle as our first rose petal, that first petal, when we plug in a 1, would be pointing up. And for a circle, we would only have one petal, so that would be the end of our graph, which is why circle graphs are different than rose petals, because rose petals we're going to have a number of petals greater than 1. So let's take a look at how this is going to work when we have something that has a higher value odd number. And the key on this is understanding that the orientation of that first petal that you draw is going to flip for each. So when n is 3, the first petal would be drawn down on the y-axis. When n is 5, the first petal would be drawn up on the y-axis. When n is 7, the first petal would be drawn down on the y-axis. And this is all going to be for positive values of a. So let's just keep it simple right now, and let's try one example of this and see how this works. And like we said, figuring out the number of petals and then the angles in between, that's going to work very similarly to what we did in the cosine video. So if you haven't checked that out and get a good framework and understanding of how rose petal graphing works with cosines first, and then we can work through sines. But if you have already watched that, or if you feel comfortable with cosine functions, then let's take a look at an example with sine. Let's do r equals 3 sine 3 theta. So here we can draw in our circles as a guide. And let's take a look at which way that first petal is going to be directed. So it's going to be along the y-axis, and because it's 3, right? So that means our first petal is going to be in the downward direction, and that's going to be present there. Now we'll take a look at our other petals. And so here, when n is odd, remember p equals n. So for this equation, we get that p equals 3. So we have a total of 3 petals. They would be spaced out, 360 divided by 3 is 120. They'd be spaced out 120 degrees. And so you'd have one here at positive 30, and one here at positive 150, and then your last one here at 270 that we started with. And so that would be the spacing of those 3 petals. And again, hopefully that's something that we're already comfortable with by now. If not, take a look at one of my other videos so that we can get a feel for how figuring out the angles and the spacing of the petals works. But the key thing here is to understand for sine functions, the way that the orientation of that first petal flips when you're talking about odd numbers. So odd numbers for n, it's going to alternate. It's up for a +1, and then down for a 3, up for a 5, down for a 7, and so on. So we'll take a look at one more example of that to start with. And let's look at something like r equals, we'll do 2 sine of 5 theta. And I'll shortcut it a little bit by writing 5 theta, but I should actually be better about putting parentheses around those. So here we can draw in our guiding circles, and let's figure out our orientation of that first petal. So here, n is 5. We know the number of petals is going to be 5, because when n is odd, then the number of petals is equal to n. And because that number is 5, the orientation of that first petal will be in the upward direction. So petal number 1 goes here. And this one's probably a little bit more difficult to visualize the spacing on because the math on it isn't as smooth as, some cases where we have like 360 divided by 3 and it comes out to 120, and it's a little bit more common of an angle. But here, if you have the 5 petals, this is going to come out to 72. So you're going to have a petal every 72 degrees. So from 90, you could subtract 72. This would be at +18 there, plus 72. It'd be at 162. It'd be at 234, and it'd be at 306. So those would be the angles of those 5 petals. And again, I'm sure you can figure out the angles, but the thing I want to make sure that we get really, really comfortable with is recognizing that based on the value of n, you need to figure out whether the orientation of that first petal is going to be up or down, because that's going to dictate where the placement of the rest of the petals goes. And if you flip that around or you're not careful when looking at the n value and figuring out the first petal's orientation, then your graph will be inverted. You might have the spacing right, but you would end up with something that's an upside down version of the correct versions that we see here. So now we have one more factor to consider when we're looking at n as an odd value, and that's how does a impact things? So let's take a look at that, and I'm actually going to use our existing graph for 3 sine of 3 theta, and I'm going to see if we can, let me just eliminate some of this, and all right, so let's take a look here, and let's change this up a bit. So we're going to, let's get rid of these petals here, and let's write this out with a negative. So we're going to talk about what that negative does. And I'm hoping that if we're thinking about it and we're doing a little bit of critical thinking, I'm hoping that we might realize that the negative value is going to do what we might intuitively think it would do. And so what does a negative usually do? It's usually going to invert things, right? We're going to take the inverse value, we're going to flip it around, and that's exactly what's going to happen with the orientation. So when you have a negative value, so in this case, originally we said 1 was up, 3 was down, 5 was up, 7 was down, and so forth. So if a +3 is down, like we saw over here, right? So a +3 had this downward orientation, then a -3 is going to have an upward orientation for that first petal. And everything else is going to be the same. Like I said, as long as you can get that first petal's orientation correct, then drawing out the rest of it is going to be a breeze. So here we have an upward orientation for that first petal based on the fact that we had the -3. So highlighting that in a different color just so we can see the change from when we had the positive versus the negative value for A. And then here, the number of petals is the same. Since it's odd, the petals would be equal to n, which is 3. So here they're going to be 120 degrees apart. 90 plus 120 would give us 210, plus another 120 would give us 330, and that would be our graph, something that looks similar to a Mercedes-Benz logo type thing. So that's the key when we're dealing with odd values for n when graphing rose petal polar equations with sine. Now let's take a look at when n is even. And this is not so bad because just like with a lot of things, even numbers for n oftentimes give us symmetry. Let's just jump into an example here. And let's try 3 sine, we'll do 2 theta. So how many petals are we going to have on this? So hopefully we remembered that n is even, and when n is even, the number of petals is 2n, 2 times n, so there would be 4 petals. In the key on this, we can look at it visually and we can look at it mathematically. I want to show you an example where we do a little bit of each. So on this, we'll start mathematically, and I'll put the calculation down here just to leave us a little bit of room. So 360 divided by 4. These are going to be 90 degrees apart from each other. But here's the key on this. When n is even, so let me write that in here as a condition, but when n is even, so we have no petals that are actually going to be on an axis. They're going to be in between those x and y axes for this. So make that a tiny bit smaller, even though it is a big point. So I want to make sure we emphasize it enough, but I'll make it a little bit smaller so that we have some room for doing the graphs. So here, these petals are going to be 90 degrees apart, and you're going to have one in each quadrant. And so we can look at this visually, and I'll show you how you can use the math on it to calculate it mathematically. It's going to extend out to that third circle, and for symmetry here, it's going to be right in the middle of each quadrant. So you might be able to visually see that, and you might even recognize that if that's where your petals are, then that would be a 45-degree angle for that first one, and then plus 90 is 135, and plus another 90 would be 225, and then plus another 90 would be 315. And so if we already know that from a visual representation, that's awesome. But if we needed to figure out exactly where it goes and we weren't sure of that initial 45-degree angle, here's how you can figure it out. The 90-degree value that you have when dividing 360 by the number of petals, if you divide that in 2, that's going to tell you where your first petal goes. So your first petal is going to be 45 degrees in that direction. And if you go negative 45 degrees, you can see that the separation between a positive and a negative 45 would be 90. So we would have a 90-degree angle between those two petals there. So hopefully we're comfortable seeing that visually, but also understanding how we could calculate those angles as needed. So let's do one more example, and just to make it fun, we'll do a negative 3 in front, and then we'll do sine of 4 theta on this. All right, so for negatives, when you have an even value for n, why do we like even values for n? Because it doesn't matter if the value of a is positive or negative, it's going to be symmetrical. So the graph for r equals negative sine 4 theta would be the same as the graph for r equals a positive 3 sine 4 theta. So for this graph, we do have a little bit of a change because we have 4 theta, which means the number of petals, which is twice the value of n. When it's even, the number of petals would be 8. So let's think of what that's going to look like. 360 divided by 8 is 45. So that means that our first, and I'm going to zoom in for this one just to be able to graph it accurately, but our first petal here, if if you divide 45 by 2, you get 22.5 degrees. So these numbers are going to be a little bit yucky, but as long as we can get that first one, and we know where that first petal goes, then here you could add 45 to every value, so you'd have 67.5, and so forth all the way around. I won't write all of them in. You can do the math on that easily enough, but I'll draw in all of those corresponding petals. So even though technically, because this is a negative value, we might say, oh, okay, well, think of it as being flipped. And maybe this would be the first one that I would draw in. But I don't want us to get in a habit of doing that, because it's going to make drawing rose petals for sines when you have an even value for n a million times harder if you try to think of a change in orientation for that first petal. What I want us to get in a habit of doing is, when you see the negative, recognizing that for our purposes, we can basically, in terms of graphing, ignore that negative value, because the graph is going to be the same as if it were a positive value when you have an even, and remember, this is only when you have an even value for a sine function when doing polar graphing of rose petals. So hopefully that makes sense. And if you want to get into some of the other polar equations that we can teach you how to graph, then check out our other videos, and thanks for watching.